All right. Hi, guys. I'm doing more final reviews, starting with number 37 on this video. Scientists experimenting with the effects of a new antibiotic on a particular bacteria population found that the population of bacteria can be modeled by that function, where T is the time in days the antibiotic is taken. Scientists have also discovered that this antibiotic can only be taken for a maximum of 5 days before it is considered harmful to the patient. In order to consider a person cured of the infection, the initial population of 2,000 bacteria must be reduced to less than 200. Is it possible to cure a person with this new antibiotic? So, what this is an exponential decay function because this value will end up being less than 1. And what we're going to need to do is see, I'm just going to plug it into the graphing calculator and see if it can go down from 2,000, which is the initial, down to 200 in less than 5 days. So graph this in your graphing calculator. So 2,000 times 1 minus 0.25, I believe. So we could have just put 0.75 to the power of t, or the power of x. I believe that's correct. Let me just check. Yep, looks good. And then we're going to go to the table and see how long it takes to reach 200. Oh boy. So it takes over 8 days to get down to 200, because it's not even technically at 200. It's still above 200 at 8 days, by a decimal, but it takes over 8 days. So since it takes over 8 days to get to 200, it won't be less than 200 until 9 days. So our correct answer is D, that no, we can't use that medication because it takes too long for it to actually cure the virus or whatever it is, the bacteria. All right, which of the following sets of equations are not inverses of each other? All right, so I'm just going to go through and look at each of these. The inverse of a log is an exponent, and this plus 2 is on the inside of the parentheses. This minus 2 is on the outside. That's opposite, so that's good. We like that. The inverse of an exponential is a log, so that's good. And the plus 1 up here becomes a minus 1 there. The plus 2 here becomes a minus 2 there. That all looks good to me. The inverse of a cube root is a cube, so that's all good. This minus 6 inside the radical becomes a plus 6 on the outside, so that looks good. This is our big issue. The inverse of a squared function should be a square root function. So those are not inverses of each other. The other thing you could do is you could plug one into the other, and if they are inverses, it should simplify to x. Or the other thing you could do is take one of the equations, switch x and y, and solve for y, and you should get the other equation. All right, what is true about a graph and its inverse? They are symmetrical with respect to the line y equals x. That is correct. They are not symmetrical with the line y equals negative x. Inverse does not always mean opposite. Opposite in math just means a negative number. Y equals 5 and y equals negative 5 are not inverses of each other. So they're not, just because they're opposites doesn't mean they're inverses. And they are opposite reciprocals. No, doesn't mean that either. It means that they are symmetrical with respect to the line y equals x, or it means if you switch x and y, you'll get an inverse, or All right, moving on. Find the x-intercept and vertical asymptote of that function. Gosh, I would probably just use my graphing calculator to make this as easy as possible. because we're on the final, you're going to want to, make it as quick and easy as possible on yourself. So log base 2. Oh, that's what I'm realizing. We can't necessarily graph this on our graphing calculators because some of them will have the log base function turned off. So we're going to try graphing this by hand. So find the vertical asymptote. So the first thing I'm going to do is change this from log form to exponential form, and I'm going to completely ignore the transformation. So I'm going to ignore this negative and this 3 and switch this to exponential form. So this will be 2 to the y equals x. And then I'm going to find my 2 critical points. So my first critical point I'm going to find by plugging in 0. Oops. And I'm sorry. I need to get into the log mindset. First thing I'm going to do is plug in 0, but I'm going to be plugging in for the y, not the x, because this is backward from how we normally do this. So I plug 0 in. Anything to the 0 power is 1. Now I'm going to plug 1 in. 2 to the first power is going to be 2. So this graph, if it didn't have any transformations, would contain the point 1, 0 and 2, oops, that's not 1, 0. It would contain the point 1, 0 and 2, 1, and then it would have an asymptote right here, and it would look something like this. That's what a log function typically looks like. But ours has 2 transformations. If there's a transformation inside with the x, you need to make sure to factor that negative out. So this will actually be x minus 3, which means it's going to shift to the right 3. And it's going to be reflected over the x-axis. So this tells us to, y-axis. This tells us to reflect it over the y-axis. So it's actually going to be more like this. But then we're going to shift it to the right 3. So this means right 3. So we'll take each of those points and we'll go right 1, 2, 3. Right 1, 2, 3. All right. So the x-intercept appears to be at 2. And it appears like we have our asymptote. Everything's been reflected. So the asymptote is where it's approaching over here. The asymptote should have been shifted over to positive 3. So it was shifted over to positive 3 because of that value there, this value here. Which of the following expressions is equivalent to this? Okay, so this is expanding log. So what we're going to do is expand this. If you don't remember the rules for expanding logs, you can go to the very front of this book, and you have all the logs for the expanding rules here. So if you want to expand 2 things that have been multiplied, you're going to add them together. If you want to expand 2 things that are being divided, you're going to subtract them. And then this power rule says any power can be moved to the front. All right, so those are the rules we're going to be using for expanding. Whew, lots of work. Okay, here we are. So first thing I'm going to do is everything on the top will get added. So natural log of e plus natural log of b squared, but I'm going to move that squared to the front. Now anything on bottom will get subtracted. So this will be minus natural log of a. This one's a little funky. This would be a is under a cube root. That's a 1/3 power, right? That's what, 1/3. That's what cube root means. but we're going to move that 1/3 into the front. Oops, 1/3. All right, and then again, minus, because it's on the bottom, natural log of c to the 5th, but we're going to move the 5 in front. So this should be our correct answer. Oh, wait, I just realized something. Natural log of e is here, but here they had 1 instead. Natural log of e can be simplified. Natural log and e cancel each other out, and what it reduces to is whatever the exponent was. Even though there wasn't anything written, there was an exponent of 1. So this should be 1 plus 2 natural log of b minus 3 natural log of a minus 5 natural log of c. I think the correct answer should be b. Trying to look for the difference between b and d. Yeah, the issue here is they did plus this. Since the natural log of c to the 5th was on the bottom, it needs to be subtracted. The only exception to that would be if we had parentheses here telling us that both of those are on the bottom, but there were no parentheses, so it's got to be b. All right, 42. Let's simplify. Looking at the answer options, I noticed that it simplifies. All the logs are going to go away. So that's kind of nice. So I'm just going to rewrite this first one as log base 4 of 4 squared. Because 16 is 4 squared. These will cancel. So this first part just becomes 2. And then natural log and e cancel each other out, so that part becomes 7. Even though it's not written, this is a log base 10. So log base 10 of 10, that cancels, and we're left with just 1, the exponent there, which is 1. And then the last one is the only kind of ugly one. We can't get 25 to have a base of 125. So what not easily without kind of a fraction. So what I'm going to do is I'm going to take this, set it equal to x, and I'm going to convert to exponential form. So 125 to the x power equals 25. I'm going to change both of these to a smaller base. So this will be 5 cubed, and this will be 5 squared. The 5s can cancel. 3x is going to equal 2. Divide by 3, x equals 2/3. So this ends up being 2/3. All right, now combine 2 plus 7 is 9, minus 1 is 8. So this will be 8 plus 2/3, which is 8 2/3. So our correct answer should be B. Give an exact solution for the following equation. All right, so this one looks more complicated, I think, than it is. What you want to do here first is combine all like terms. So we've got 42 plus 2 times 8 cubed. This is just one term. Even though it looks like it's kind of spaced out, there's no pluses or minuses there. That's a single term. Same with that. That is together. That's one term. So I'm going to get the 42 and the 14 on the same side, and then the x to the 8ths together on the other side. So I'm going to subtract 14. 42 minus 14 is 28. So this will be 28 equals, then what I'm going to do is I'm going to do minus 2 times 8 to the x on both sides. These are like terms, meaning this part can just stay the same and I just subtract the coefficients. So 3 minus 2 just gives us 1 times 8 to the x. I don't even need to write the 1. I can just leave it as 8 to the x. So we got like terms together on each side. We have 28 equals 8 to the x. Now is when we're going to either solve by logging both sides or do the loop method to get x by itself. I'm just going to solve by logging both sides. I think that's how the answer is going to look most like. So I just log both sides. The whole point of doing that was so that I can move x in the front. So this will now be log of 28 equals x log 8. Now the final step to solve for x is to divide by log 8. So x should equal log 28 over log 8, which is D. Okay, 44. This one we actually, if you look at the answer options, there's no log written. So we don't need to use logs. We can actually get these to have the same base. And if we can get both sides to have the same base, then the bases will cancel. So I'm going to change this to a fraction. This is 5/2 as a fraction. And then I want them both to have the same base. It's typically easiest to change the bigger one to become the smaller one. So we're going to leave this as 5/2. And then this one is going to become 5/2. 125 is 5 cubed. 8 is 2 cubed. So basically, this was 2/5 to the third power. And then we still have this 2x plus 4 on the outside. So I just changed the base, so now they have the same base. I can cancel the bases and solve what's remaining. So 8x minus 4 equals 6x plus 12. Subtract 6x, we get 2x minus 4 equals 12. Add 4, we get 2x equals 16. Divide by 2, x equals 8. On a test like this, you could always do guess and check too. Plug in those values into your calculator and see if you can get the left side to equal the right side. That's what I would do if I were stuck. All right, 45. If we have just one log on each side and they're the exact same log, they can cancel out. So all we're left with is 2x equals x squared. Then because this is quadratic, we need to get everything on one side and factor. So I'm going to get 0 equals x squared minus 2x. Since there's only two terms, I just take out a GCF. So the GCF will be x. I'm left with x minus 2. So my answers end up being 0 and 2. But keep in mind, you can't take the log of 0. So it can't be this because you can't take the log of 0. It's just going to be 2. So our answer should be C. Remember, can't take the log of 0 or a negative. So if I were to plug 0 into this, that would end up being log of 0. That's why that answer doesn't work out. All right, just a couple more. Solve. Let's see. On this one, I'm going to get the logs on the same side first. So I'm going to do log base 3 of x plus log base 3 of x plus 6 equals 3. And then I don't like that I have two logs here. I can't just cancel them out because this 3 is in the way. So I need to combine these two logs. I'm going to condense them using my condensing rules. I can condense these into one log as long as I multiply x times x plus 6. So in order to combine, I have to multiply them. This will become x squared plus 6x. Okay. Now that they are condensed into one log, now I can use my loop method to convert this to exponential form. So I'll start with 3. 3 to the third power is going to equal x squared plus 6x. Now 3 to the third is 27. So this will be 27 equals x squared plus 6x. Get everything on one side, factor, and solve. What multiplies to negative 27 but adds to 6 is going to be 9 and 3. The 3 will be negative. So my factors will be x plus 9, x minus 3. My solutions will be negative 9 and positive 3. But we can't take the log of a negative or 0. And if I were to plug negative 9 in there, that would be log of a negative. We can't, so negative 9 is not going to work. So just 3 will work. So, and if we plug 3 in, we don't get any negatives or log of 0. So that works out. So our answer should be C. All right, and then the very last one. The table below shows the balance of my savings account at the end of the year. At the end of the year. Which model would best fit the data? Linear, logarithmic, or exponential? So linear means it's going up by a constant amount each time. Logarithmic means it goes up by a fair amount and then it kind of levels off. So linear, let me just draw examples. Linear is going to be kind of like this, constant amount each time. Logarithmic is going to look more like this, where it starts going up, but then it kind of levels off. And then exponential is the opposite of that. It starts off slow, but then it speeds up. So this goes up by 200. This goes up by, 190. This goes up by, 50. And then this only goes up by 20. So what appears to be happening is it was going up, but now it's not going up by quite as much. It's leveling off a bit. So that's going to be logarithmic, where it levels off and stops increasing by quite as much. All right, that is it. Thank you.